When finding inverses, radical equations come up an awful lot. So we need to be able to graph them. And
we're going to follow the same process as we did with parabolas, where we actually write them in this sort of vertex form and translate our parent function. So this right here, y equals square root x, this is our parent. So let's go ahead and graph it. So my start point is the origin, so 0, 0. So I'm going to start right there, and there it is. And now, if I go right 1, instead of squaring it like we did, this is a square root function, so if I go right 1, the square root of 1 is 1. So I'll go up 1. Now, normally, with the parabola, we would go right 2 next. But square root of 2, I could try to do that, and I could use a calculator to help me if I wanted. But that's not going to work out really well. Neither is square root of 3. But the next one that'll work out is square root of 4. So if I go right 4, so 1, 2, 3, 4, the square root of 4 is 2, so I'll go up 2. And then if I go right, not 5, not 6, not 7 or 8, but 9, the square root of 9 is 3, so I'll go up 3. So with parabolas, we also went left. But if I go left 1, I get square root of -1, which is I. Now, I'm not going to be able to graph in the imaginary plane right here because I have x and y. I don't have any imaginary. So any of the negatives are not going to work out. So let's suppose for a second that I did y equals negative square root of x. Well, now this is my stretch, and my stretch is a -1, which actually ends up being a reflection over x. So if I were to reflect these, and I'll go ahead and do this in a different color, I'll do it in blue. I start at the origin, I go right 1, the square root of 1 is 1, I would go up 1, but I multiply by my negative, so I go down 1. If I go right 4, the square root of 4 is 2, but times my negative, so down 2. And if I go right 9, the square root of 9 is 3, but times my negative, down 3. So this is that one. So that's if we have a negative in front. We need to remember to take care of that. Now suppose I have y equals square root of x plus 2. Well, this means up 2. So I'll attempt this one. I'll do this one in red. So I'm going to move this up 2. So my start point is not 0, 0. It's 0, 2. So I start right here. If I go right 1, the square root of 1 is 1. If I go right 4, the square root of 4 is 2, so up 2. And if I go right 9, the square root of 9 is 3. And that gives me that parabola. Or not parabola, that radical function. Notice there's no bottom, there's no left, there's no reflections of any kind here. This next one is -2 on the outside, so that means I'm going to go down 2. So I'm going to start not at 0, 0, but 0, -2. So that's right here. If I go right 1, square root of 1 is 1. If I go right 4, square root of 2 is 4. If I go right 9, square root of 9 is 3. I went up 3. And there we have a bunch of these radicals graphed. Let's clean this up a little bit by going to a clean graph. Let's try these. Now, in this case, I have a less than, so I'm going to have some shading involved. So remember, if it is less, but not equal, I'm going to be dotted. So I have a dotted line right here, and I'm going to shade below. All right, so what's my start point? Well, this time it works just like with parabolas. So this minus, we have this kind of vertex form here. It's kind of like a vertex form. Y equals A is our stretch, square root, x minus h plus k. And my start point, it's not really a vertex, but my start point is h comma k. So I'm going to start at 0 or 3, 0. All right, that's right here, 3, 0. And now I do the things I was doing before. If I go right 1, square root of 1 is 1. If I go right 4, square root of 4 is 2, so up 2. And if I go right 9, Square root of 9 is 3. And this time it's dotted because I'm less than. And then I'm going to shade below. So when I shade below, it's only below this line. It's not anywhere else. I'll do this next one in blue. So what's my start point? Well, I'm going to start at -1, 0. And then I do the same things. Square root of 1, 1. Square root of 4, 1, 2, 3, 4 is 2, up 2. And square root of 9 is 3. And this is also dotted. And then this one shades above. Notice it's only where this actual line is. I'm not shading over here, notice, because I don't have any negatives. Now when I'm doing these, I might be concerned with my domain. So let's take a look at this one. So this one's domain, x minus 3, this has to stay positive or 0. So x has to be greater than 3. Okay, so that's my domain. But I might also be wondering about my range. What's the range of this thing? So as I look at my graph, I notice, well, what are my possible y values? Well, if it weren't for the less than case, let's say it was an equal to case, let's say it was equal, my y values seem to start at 0 and go up. So if it weren't like this less than, because I do have ones that are going down here, so really it's everything. Y does end up giving me everything. But if it were an equal to case, it would start at 0 and then go up from 0. And then here, what's my domain? X such that x is greater than or equal to -1, because this has to stay positive. So let's look at the graphs from before. I don't know, let's just do the next graph. All right, here's a weird situation. So now we have something in here. We have something in front of x. I generally want this to be a 1. Okay, now I can do it without that being a 1, but it's a lot harder. So no matter what this is, I'm going to factor it out. And I have it such here that it'll work out just fine. Factored out my 9, and then I can split this up, and the square root of 9 is 3. So 3, then x plus 2. So where do I start? Well, I start at 0, -2, and now I have a stretch factor. My stretch is 3. So let's start graphing this. I'll do it in blue. So 0, -2 is right here. And if I go right 1, the square root of 1 is 1. So I go up 1, but times 3. So times 3. So I'll go up 3 instead. If I go right 4, square root of 4 is 2, but times my stretch at 3 is 6. So I'll go up 6. 1, 2, 3, 4, 5, 6. If I go right 9, square root of 9 is 3, but times my stretch of 3, up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And this is going to be a solid line because it can be equal to. So solid. All right, and I shade above this. Okay, going on. All right, this one, where do I start? -4, -5. And I have a stretch of, and I'm going to change this. I'm going to do, well, no, that's fine. I have a stretch of 3. Okay, so I start at -4, -5. And then I go right 1. Square root of 1 is 1, but times 3, so up 3. 4. Now, why am I not choosing 2 or 3? Because those square roots I don't know. So if I go right 4, square root of 4 is 2, times 3 is 6, so up 6. And if I go right 9, so 5, 6, 7, 8, 9. Square root of 9 is 3, and times my stretch of 3, so up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is going to be a dotted line. And then I shade below this. Now let's say, for the sake of argument, let's say that this was actually y equals 3 square root x plus 4 minus 5. And I wanted to know, well, what's my domain, what's my range? So no shading, what's the domain and range? Well, all of this stuff for my domain has to be bigger than 0. So x has to be bigger than negative 4, and I see that to be the case. I start at negative 4 and I go to the right. For range, I see that the graph is right here, and then it goes up from there. So my range is y, such that y is greater than or equal to negative 5. And do you see where I got that? Negative 5.